Previously in Calculus 1, we developed the concept of the definite integral to calculate the area below the curve on a given interval. So in this chapter, we will expand that idea to calculate the area of a more complex region. We start by finding the area between the two curves that are the function in terms of x. Okay. So the idea, when we start the area underneath the curve, the idea was you divide the interval a, b to sub-interval, depend on how many rectangle you are using. And we will let the number of this rectangle go to infinity, and we add the sum of the area of each rectangle to find the area underneath that curve. It's exactly the same idea now. However, remember the area underneath the curve, the two curves f of x and g of x, is the area under the curve of f of x minus the area under the curve of g of x. And by property of integral, we are writing that together in one single integral, that is the area underneath the curve of f of x and g of x. The area bounded by the curve f of x and g of x is given by a equal the integral from a to b of f of x minus g of x dx. Okay. So for example 1, let's find the area of the region bounded by the two curves y equal 2 minus x squared and y equal to negative x. So let's first of all take a look at what this curve look like. Let's make a rough sketch of this. The first curve, y equal 2 minus x squared, this is a parabola open downward and that move up 2 units. The vertex is 0, 2. Okay. When x is equal to 0, y equal 2. When y equal to when y equal to 0, we're looking for the x-intercept, and x equal plus minus square root 2. So let's take a look. This is a negative root 2, and this graph is not to scale. So this is the parabola that we are looking at. The line that is y equal negative x is this line. Okay. So the region that we want to find the area on is this little region. Our first step in calculating this is to find the intersection of the two curves. To do that, I take the two curves and set it equal to each other. 2 minus x squared equal negative x. X squared minus x minus 2 equal to 0. We can factor this, x minus 2 times x plus 1 equal to 0. So x equal 2 and x equal to negative 1. So the two intersection of the curve is a curve here at x equal to negative 1 and here at x equal 2. Okay, at x equal 2. Now, the second step is to then set up the integral. The area underneath the curve is the intersection from negative 1 to 2 of f of x, that is the curve above, 2 minus x squared, minus the curve that is below, dx. This is the integral from negative 1 to 2 and we'll clean this up. Negative x squared plus x plus 2 dx. And let's evaluate this integral. This is equal to negative 1/3 x to the third plus 1/2 x plus 2x. And we want to evaluate in this between negative 1 to 2. Plug 2 into the polynomial. And we get, and that is 9/2. The next problem, we're looking at the curve that bounded by the line y equals square root of x and y equal to x minus 2. Again, first step, let's make a rough sketch of the curve. Y equals square root x. So 1, 1, 4, 2. The line y equal x minus 2 that have the y-intercept at negative 2. The x-intercept when y equal to 0 at 2. The x-intercept at 2. And we have the y-intercept at and what happened when x equal 4? When x equal 4, y equal 2. So we're looking at this line. Okay. Let me go ahead and extend in this. Let's add a little bit into the instruction. We want to find the area of the region bounded by the curve square root of x, y equal x minus 2, and the x-axis. X and the x-axis. Okay. So the region under the curve that we are looking for is this region. Okay. Note that this curve, the two curves split that region into two different halves. So we have the first half bounded by the curve y equals square root of x and the x-axis. The second half, we have the curve that bounded by square root of x and the line y equal x minus 2. So we have two areas here. So area 1 and area 2. Okay. Look like the area 1 is between going from 0 to 2, and area 2 is the integral from 2 to 4. And we know that the curve y equal x minus 2 and y equal square root of x intersect at x equal 4, right? When y equal 2, x equal 4. So then I can set up my integral as the area is equal to the first intersection from 0 to 2 of square root of x dx plus the integral for the second part 2 to 4 of square root of x minus x minus 2 dx. So 0 to 2 x to the 1/2 dx plus 2 to 4 square root of x, or x to the 1/2 minus x plus 2 dx. We'll calculate this integral and evaluate. So the integral of x to the 1/2 is x. So we add 1 to 1/2 to make 3/2, multiplied by the reciprocal 2/3. Evaluate from 0 to 2 plus 2/3 x to the 3/2 minus 1/2 x squared plus 2x. Evaluate from 2 to 4 and we get 10/3. The next one, we're looking at the region bounded by y equals x to the 3rd and y equal x, and the line y equal x. Again, let's get the curve. And again, this is not to scale. Okay. The line y equal to square y equal x is this line. So the curve that we speak of is this 2 curve. Note that y equal x to the 3rd and y equal x intersect each other at plus and minus 1. So we have 2 parts of the curve. We have one part of the curve where called as A1, that is from the interval from -1 to 0. And the curve x to the 3rd is the curve that is on top. Okay. And then we have the second part, A2, where the curve, the line y equal x is the one that on top, and it is from the interval from 0 to 1. So the area underneath this curve, y equal x to the 3rd, the area bounded by the curve y equal x to the 3rd and y equal x, is calculated by adding up the area in part 1 and the area in part 2. Okay, so note that I'll calculate in this area by first go, okay, the area is equal to part 1 from -1 to 0, x to the 3rd minus x dx, plus the second part will get 0 to 1 of x minus x to the 3rd dx. Note that the curve x to the 3rd and y equal x, the area 1 and area 2 is equal to each other by symmetry. Then I can rewrite this area. I can just say, well, I can just calculate this one time. This area equal twice, and I'm going to calculate 0 to 1 of x minus x to the 3rd dx. Now this equal to times 1/2 x squared minus 1/4 x to the 4th. And we evaluate this from 0 to 1. So this is just 2. 1/2 minus 1/4. That is 2. 1/2 minus 1/4. That is 1/4. So this area is 1/2 unit square.